Hi, everyone. This is going to be an interesting one because this is actually my third attempt at this. We've had technical issues the first two times, and you may notice a slight edit towards the end of the video, ruining the illusion that I did this all in one take. But we are here today to talk about heaps and priority queues, which is one of the more advanced topics in a basic data structure class. It is a little more mathematically oriented, at least conceptually, on why it works, how it works. So let me get into my screen sharing, and we can get into this into some detail. So we're going to start with priority queues themselves. And we'll talk a little bit about self-balancing trees before we get into heaps and how heaps work. And then we will finish up with how priority queues and heaps kind of come together and what their relationship is. And then we'll finish up with a coding example of the traditional way that we do a heap and a priority queue in computer science. So let's talk about priority queues briefly. If we think back to queues, queues are a FIFO data structure. The order of output is determined by the order of input. And that's useful for a lot of things, right? But it's not always useful. What if we want to remove things based on importance instead of the order in which they were inserted? And this happens all the time. If you think in your own life, you'll go, well, actually, and the classic one is hospital, is an ER, right? And this comes from, wow, I'm out of practice. This comes from battlefield triage, right? Hospital triage comes from battlefield triage. And the idea that you need, when you're on a battlefield, to be able to say, who is the most important? Who do I need to help, right? And there are really three levels. You can wait, you can go now, or it's too late. And I know this is grim, but this is where this comes from, right? And so the now, this is your critical priority, right? If you have someone who has a chest wound versus a broken arm versus something truly grim, you want to do the chest wound. You can save the chest wound. In a hospital, you can save the person with the heart attack, right? But you got to treat them now. And I will tell you, modern hospitals don't have too late. That's really not a thing that gets done in an ER. But the idea of going, okay, can I help this person, but only if I take them now, versus can they sit there for a bit? Right? Another classic example is ticketing systems. Anyone who is a software engineer will tell you that a ticketing system is prioritized. Right? Bug reports tend to be the highest priority because they tend to be out in the wild already. And then there tends to be like immediate, high, medium, low, right? Something like that. These are standard ways of saying, hey, I need to put things in the order in which they occur, but I need to take them out in an order based on importance. And this is where priority queues come in. Items are removed based on the priority they have, not by the order that they come in. So priority is determined by some value, and we'll talk about how this can be represented. But traditionally, and this is not an absolute, but traditionally, lower valued priorities are considered to be higher in importance. In English, the phrase priority one, right? Okay, this is priority one. This means top priority, highest priority, immediate priority. So it can be a little confusing sometimes, right? A higher priority has a lower value. And items of equal priority are actually removed arbitrarily. Think about a SQL query. When you query a SQL engine, you're not allowed to assume that the records that come out are in any order, right? They usually are, especially if it's a simple table. They're usually in the order that the primary key puts them in, or the order in which they are inserted, or both. But you're not allowed to assume that unless you have an order by. Okay? Output from a SQL engine is considered arbitrary. Output from a priority queue. 2 items of the same priority are arbitrary. And the reasoning is this. If you said, well, that one went in first, that one should come out first, that's great. You should have given it a higher priority. Because you are saying that inherently that thing has an importance that you did not fully express, right? That is the argument. If you wanted it to come out sooner, you should have given it a higher priority. So just do keep this in mind. If 2 items are tied for highest priority, you cannot depend on which item will be returned first. You might have a million things with the same priority and then say, hey, give me the next one. And you get the most recent thing inserted. That's totally legal.